Hey everybody, welcome back. Hopefully you had some good connections there in the breakout sessions that went faster maybe than we were all expecting, but hopefully you made some connections that you can follow up on in the future. So our next presentation is by Dr. Jim Myers, who is a breeder at Oregon State University. And it's really fun to have him presenting to us today. He's been out to Hawaii, involved doing some teaching with some variety showcases that we've done with some community science work. And he's a pea breeder, a pepper breeder, a tomato breeder, a broccoli breeder. I'm sure even other things that I've left out. And just has been a real inspiration to many of us and a real fixture in the organic seed community. And so he's going to share with us today on how to do hand pollinations if you're wanting to purposely cross some different things together to create variation to then do selection. So thanks so much, Jim, for presenting today.
Well, yeah, thanks, Jay. And just before it disappears, I put some links to some of the videos I'm going to show today in the chat, and then a link to some other crossing resources. So check that out if you're wanting to. I'll share my screen here. Does that look okay? Good. Okay. So we put together a couple of videos here on crossing tomatoes and crossing beans. And I think, well, just to back up a little bit, I've kind of helped out with some of the projects, getting some of the projects going in Hawaii, especially on the tomatoes. And, we can do the crosses and send that seed over, but, it'd be nice if everybody could make their own crosses. And so I think that's kind of the purpose here, is to provide you with some information on how to do that. Just make a quick tour of what we generally have in our toolbox for crossing. And you'll see, if you look at the right side, you'll see a pair of forceps. Forceps are quite valuable, although I would say that you can make tomato crosses with a sharp number 2 pencil if you have to. So that's really pretty easy. These are really pretty necessary though for something like crossing beans. Scotch tape is useful. You'll see how that's being used. This little jar has ethanol in it. You could get some Everclear and use that, or isopropyl alcohol, just for killing the pollen on your forceps in between making pollinations. You have crossing tags here. These are jewelry tags that you can write on and then hang on the cross so you can come back and find it when you're done. And then when you get to be my age, what's really essential are these jeweler's headset for magnifying the plants, the flowers when you're working with them. So that's another thing that's quite useful, particularly for something like beans. So we'll start out with tomato first. Tomato is a self-pollinated crop, so it's easy for it to self, but the crossing is the difficult part. Despite that, we still managed to make F1 hybrid tomatoes, and that's all done by hand. So this is an image of a tomato flower. You can see the petals, the green sepals behind the petals. Then there's this anthercone that has where the pollen is contained. The pollen is released in little slits on the inside of this anthercone. And then the style and stigma are inside that, where you want the stigma is where the pollen has to get to then to start to germinate and start growing and go down to the ovary and fertilize the ovules. In tomatoes, in many cultivated tomatoes, the stigma the style is short, so the stigma is within the anthercone. But in wild species and some cultivars, you'll see the stigma extends beyond the anther cone. And that tends to lead to greater outcrossing. So these techniques are generally applicable to other flowers in the other crops in the nightshade family. Here are peppers, some of the different species of peppers. You can see the flowers generally have these free anthers, but otherwise the structure is very similar. And what we say today about tomatoes would work very well for um, peppers as well. Eggplant, main difference in an eggplant flower is that the pollen is released out of these little pores at the tip of the anther rather than the slits on the inside of the anther. Potato flowers are very similar to the eggplant flowers in terms of the morphology of the anthers. Potato flowers are actually kind of an exception because potatoes tend to be outcrossed, and so it may actually be more difficult to self-pollinate a potato plant than to make a cross. And then finally, the things in physalis. The Cape gooseberry flower is what I picture here, but other flowers that species in this family would, or in this group, would be tomatillo and ground cherries. So I'm going to start a video here, and
This video includes a demonstration on using hand pollinations to make crosses in common tomato, Solanum lycopersicum. To begin, you'll need to identify flowers at the appropriate stages for pollination. The paternal parent will be an open flower, which is indicative of pollen shed. The maternal parent will be an unopened flower, just beginning to show some petal color that is within a day or two of opening. If you look at these examples, you can see both maternal and paternal parents that are at varying stages for successful cross-pollination. It is important to note that the maternal and paternal flowers will be at different morphological stages, and due to this, you will need to have tomatoes at varying stages of flowering to begin making cross-pollinations. Once you have determined the presence of both paternal and maternal flowers, you can move forward to the emasculation of the maternal flower. The emasculation of the maternal flower is done prior to flower opening to ensure that pollen shed has not begun and that self-pollination will not occur. It's best to do pollination early in the morning to find flowers at these stages. There are two stages of the emasculation process. These are the removal of the sepals and petals and the removal of the immature anther cone. You'll begin by grasping the base of the maternal flower and removing the green sepals and the white to greenish yellow petals. This will give you a clear view of the anther cone in the flower. You will then remove the immature anthers. They are pale green in color, unlike the bright yellow anther cones seen in the mature flower. The anther cone is detached from the calyx and can either be removed in one piece or anther by anther. Be very cautious during this step to avoid damaging the style and stigma. At this point, the emasculation process is complete, and it is time to prepare the paternal flower. Prior to beginning the emasculation process, you should have identified a flower at the appropriate stage for pollen donation. There are 4 steps in this part of the hand pollination process: removing a portion of the anthers, brushing or tapping the anthers of the paternal flower onto the emasculated maternal flower, the removal of all other flowers from the same flower cluster as your maternal flower, and finally labeling your cross. Begin by bringing the paternal flower close to the maternal flower and remove several anthers from the paternal flower using forceps. Pollen is shed from vertical slits on the interior side of the anthers, and this is the side you want to come in contact with the stigma of the maternal flower. Bring the anthers to the stigma of the maternal flower and distribute the pollen by gently brushing the anthers against the stigma. You can also tap the anthers above the stigma to release pollen. Once the maternal flower is pollinated, you should remove all other flowers growing in the same raceme. This step can be done at any stage during the crossing process, but waiting until the end allows you to have other flowers available in case the crossing attempt fails. In the final step of hand pollinations, you will want to make note of the cross that was made. We use the notation of maternal parent name crossed by paternal parent name. You may also include other relevant information on the label, such as the date of the cross-pollination or the name of whoever made the cross. This information is written on a jewelry tag, and the string of the tag is looped around the pedicel of the flower. Do not hang the tag on the base of a leaf petiole or on the stem next to a raceme. Fruit may form on adjacent racemes, making it impossible to know which fruit resulted from your cross. Temperatures below 55 degrees Fahrenheit and above 85 degrees Fahrenheit will prevent successful cross-pollination, so if possible, maintain growing conditions between these two extremes. By following these steps and practicing your technique, you should be ready to successfully make crosses through hand pollination of tomato. Tracking other metrics such as temperature or time of day when cross was made may help you to further refine your process. We hope that you found this tutorial helpful. This video was put together by a team of researchers in the Vegetable Breeding Lab at Oregon State University. On a final note, we would like to acknowledge our funding sources that allowed us to put time into creating these videos. Thank you.
That was tomatoes, and we have beans now to go through. I think the best thing to do is go through the beans, and then we can take any questions people might have at the very end here. So with beans, the flowers are a bit more complicated structurally, and among the legumes, they're probably the most convoluted flower. Bean flowers have, they have this 5 petals. They have this standard or banner petal that sits back behind. Whoops. I'm going to have to reshare here. Let's see. Okay. Sorry about that. Let's see. Okay, we're talking about the flower parts, the banner petals. There are 2 wing petals, and then there's a keel petal, which is rotated more than 360 degrees. And so this is what makes it challenging when you're making a cross with beans here. So when you have when you have the technique for beans, you've got it for other types of legumes. Here are some peas. You can see they don't have this rotated keel, so that makes them a lot easier than the others to do. And then here's a just to graphically show a pea flower that's been taken apart, so you can see the banner petal up at the top, the two wings, and then the keel petal down at the very bottom. It's actually two fused petals. And then you have a staminal column and supporting your stamens and your anthers. And then inside that you have your the carpel with the ovaries and the style and stigma. So next video.
This video includes a demonstration on using hand pollinations to make crosses in common bean, Phaseolus vulgaris. Due to flower structure in legumes, these methods are broadly applicable to other legumes including runner bean, pea, sweet pea, fava bean, peanut, and others. To begin, you'll need to identify flowers at the appropriate stages for pollination. The paternal parent will be an open flower, which is indicative of pollen shed. The maternal parent will be an unopened flower that is within a day or so of opening. If you look at these examples, you can see both maternal and paternal parents that are at varying stages for successful cross-pollination. It is important to note that the maternal and paternal flowers will be at different morphological stages, and due to this you will need to have beans at varying stages of flowering to begin making cross-pollinations. Once you have determined the presence of both paternal and maternal flowers, you can move forward to the emasculation of the maternal flower. The emasculation of the maternal flower is done prior to flower opening to ensure that pollen shed has not begun and that self-pollination will not occur. It's best to do pollination early in the morning to find flowers at these stages. There are 6 stages of the emasculation process: the separation of the banner petal, the folding back of the banner petal, the removal of wing petals, the removal of the fused keel petals, the removal of the 10 anthers, and a confirmation of no remaining anthers on the flower. You'll begin by opening the outer petal, known as the banner petal. You can do this by identifying the line that divides the petal along the base of the flower bud and separate it using forceps. You will then gently fold the banner petal back and away from the remaining petals. When folding back the banner, be careful not to damage it, as you'll want to keep it for future use. Once the banner has been folded back, you will identify the wing petals, which are tucked directly inside of the banner petal. You will remove both wing petals. The wing petals are attached to the keel petals, which surrounds the reproductive organs. You will want to leave this portion of the flower undisturbed until the wing petals have been removed. Then, using the forceps, you will begin opening the keel petal. To do this, gently grasp the petal near the base, being careful not to grab any tissue beyond the petal. Slowly begin to unfurl the keel, being very cautious to not break the stigma, which is coiled inside of the keel petal. This stage can be the most difficult as the stigma is small and fragile. If broken, you will need to begin the process on a new flower. Ideally, you should be able to remove a strip of tissue from the keel petals that runs from the base to the tip where the stigma is located. Often, however, the strip runs out and it is necessary to continue the tear to the tip of the petals. Once the keel is removed, you should be able to identify the 10 male organs or stamen and the 1 female organ, the stigma. Since this flower will be the maternal parent, you will remove all 10 anthers from the stamen and keep the stigma intact. While removing the anthers, be sure to count them to ensure that the emasculation is complete. If an anther is left behind, it could begin to shed pollen in the coming days and interfere with your desired cross-pollination. At this point, the emasculation process is complete, and it is time to prepare the paternal flower. Prior to beginning the emasculation process, you should have identified a flower at the appropriate stage for pollen donation. There are 6 steps in this part of the hand pollination process. Flexing one of the wing petals, removing the pollen-covered stigma, brushing or hooking the pollen donor stigma onto the maternal stigma, closing the banner petal, taping the petals shut, and final steps to ensure successful pod set. To begin, bring the paternal flower close to the maternal parent and extract the stigma from the paternal flower by pressing on a wing petal. This should cause the stigma to protrude out of the keel petals. While holding the wing petals in a flexed position, remove the stigma from the paternal flower. It should be covered in pollen from its own anthers. Here you can see a close-up of the pollen on the paternal flower's stigma. Bean pollen is gray in color and looks like small grains of sugar coating the stigma or styla brush. Carry out the cross-pollination by sticking the 2 stigmas together. You can try to hook the paternal stigma onto the maternal stigma, leaving it behind when you close the outer petals, or simply brush them together to distribute the pollen. Once you have finished pollinating, carefully close the banner petals around the stigma to retain high humidity within the flower. You can then gently pinch the banner petals closed with a piece of Scotch tape. In the final step of hand pollinations, you will want to remove all other flower buds that are growing on the same flower cluster as your hand pollinated bud. Additionally, it is important to make note of the cross that was made. We use the notation of maternal parent name crossed by paternal parent name. You may also include other relevant information on the label, such as the date of the cross-pollination or the name of whoever made the cross. This information is written on a jewelry tag, and the string of the tag is looped around the pedicel of the flower. Do not hang the tag on a leaf petiole, at the base of the raceme, or on the stem next to the raceme. Leaf petioles may drop before you harvest the mature pod, and other pods may form on the same raceme as your cross, making it impossible to know which pod resulted from your cross. By following these steps and practicing your technique, you should be ready to successfully make crosses through hand pollination. Tracking other metrics such as temperature or time of day when cross was made may help you to further refine your process. As mentioned earlier, it is best to perform crosses early in the morning because as the day progresses, anthers in the flower you are crossing on may have begun to shed pollen. We hope that you found this tutorial helpful. This video was put together by a team of researchers in the Vegetable Breeding Lab at Oregon State University.
Okay, those are the 2 videos, and I would just finish up with a little bit of information on that's also available on eOrganic on making crosses, not only with beans and tomatoes, but several other crops as well are included in this list. It also has an alternative method for making crosses in beans that is somewhat easier than what we showed you here. The advantage to the the technique that we showed here is that you can be absolutely sure that you have a cross. The technique that is demonstrated in the organic handout is one that is there's a higher probability of having an accidental self happen. So that's those are the trade-offs, I guess, with those particular systems. So that's everything I have. There's some links to the videos. We are going to get the tomato video up on YouTube. I don't have that link yet, but here's a box link that should be good for you. And I would, if we have time, I would be happy to answer any questions people might have.
Thanks so much, Jim. I just wanted to point out to everyone, I put in the chat a wonderful paper that Jim recently published with others on the domestication of beans and their movement into the old world, which some of you might find of interest. And then I'm just wondering, Jim, is it just like a kind of species or species by species thing or genus by genus thing? Like, it seems like the beans need for the pollen to stay humid versus tomatoes that doesn't matter. They can just kind of be like out in the open. And I guess sort of related is, do you find different rates of success in doing crosses like in a greenhouse or nursery versus out in the field?
Yes, all those things matter. There are species differences in how tolerant they are of desiccation of their pollen. That's why we use the tape with beans. We don't generally have to worry about it with tomatoes. There's a big difference in trying to make crosses in the greenhouse and the field. The field's going to be a lot more difficult. And in fact, in a field situation, you might want to use some kind of cover on a tomato flower when you're trying to make a cross there. So yeah, those are all details. A lot of it, is just trying things out and figuring out what works, what your success rate is, and learning from that. In general terms, I guess I can give you some figures. For example, in peas, I can have a success rate of about 95% or so of the crosses I make will take. But in beans, it's 50 to 75% is more like what I get. Tomatoes, you can generally be pretty successful, although it'll vary depending on what you're working with. If you're working with wild species, then your success rate will go down as well. So the bigger the flower, the easier to manipulate, the less damage you do to it, the better your chances of success will be in making a cross.
Thank you. Any last question for Jim Myers before we move on to seed cleaning and drying? Okay, Jim. Well, thanks again, and thanks for all the collaboration that you have done and continue to do with us in Hawaii. Thank you.
Yeah, thank you. And it's a group I enjoy working with.
All right. Well, next, guys, we're going to watch a couple of videos. First by Dr. Daniela Dutra Elliott of Leeward Community College on the importance of drying your seed and some different techniques and equipment to do that with. And then we're going to watch a video by Evan Ryan on some different harvesting and processing techniques. And I think after we watch these, then we'll all come back together and have some question and answer time on seed cleaning. So we'll start with Daniela's video.
growing high quality be quite challenging. So we're going to talk about some of the simple techniques you can use. If you're going to be using your seed in less than 5 years, these are some of the things you can do. First, you want to dry and store your seeds at about 20 to 50% relative humidity with a temperature below 70 degrees Fahrenheit. If your relative humidity is already below 50 and you really want to track this, you want to use a hydrometer to figure it out what your ambient relative humidity is, right? So if you know that your relative humidity is below 50, then you can dry your seeds without a lot of these artificial methods I'm going to be talking about. But that's not usually the case in many areas in the tropics. So you want to make sure that you know what your relative humidity and your temperature are in your area, but also inside seed containers, inside areas where you're drying seeds. So this one on the left, it's quite inexpensive. I really like it because it has a nice digital area. I like this one on the left because it has a probe, so you can have them outside a refrigerator and you'll be able to read that relative humidity. At the same time, the probe is inside of the refrigerator. So quite nice to be able to always be able to read that information. These little ones, you can throw them inside seed boxes, containers, areas where you're drying seed. Super handy to have that around. They come in all different shapes and sizes, and it's really about what is helpful to you. So it's really important to get your seeds out of the field as soon as you can at an ideal point, because you don't want fungi and also predators attacking your seeds. So in this case, we cut this roselle, all the branches, hung it upside down under an easy corner tent, and this will help prevent birds but also mice from getting to it. At the same time, there's wind blowing through. These seeds are dropping into the shade cloth and they're getting collected there. And as soon as we can, we're gonna get them out of this area from this initial drying into an indoor situation where we can dry them even further. If you need to dry your seeds faster because your conditions are not very good, you can always process them in a different way. So in this case for roselle, instead of hanging, we can just remove those ovaries from the plant and start the drying process. It's a lot more labor intensive, so it's not ideal, but if you have to, you can do this. And you would see that things will dry out way faster. Once you have all your ovaries and all your seeds in that tray, you can prop it up and then use a fan. And it really depends on the quantity of seeds you have. It can go from a small fan to a very large fan, but really force that air through to dry that material as soon as possible so fungus and bacteria don't take over your seeds. If you don't have a lot of seeds to dry, this is a really nice option. It's a food dehydrator that you can use for seeds. However, you shouldn't use the heat element. You should be able to install this little switch. It's really simple to do, where you can not have any heat, just regular room temperature air blowing through it. So the air comes through that point, and you can remove this panel right here and then install that little switch. I can give you directions on how to do that later. But this is really cool because it comes with different options, different shelves to dry your seed. You can, if your seed is big enough, you can put directly in there. If not, they normally come with inserts. And then you can spread your seed around there and then let that dehydrator do its job. It's going to push that air through it. And you can see here I have some double butterfly pea seeds. They need to be dried. So I'm just going to put this here, spread them around, and you can fill up this entire dehydrator before you can ship them or do anything with them. So just important not to have that heat. If you're doing large quantities of seeds, you can get a seed dryer, and they come in all different sizes, and they're really nice because they force air through it and dry the seeds really nicely, and you can control temperature. So a nice option to have. Another option to have to finish drying your seed is a typical self-defrosting home refrigerator that can be maintained at low relative humidity. However, the newer versions of refrigerator that have a dual evaporator are not great for seed drying. So you really need to make sure that the refrigerator you're using is a self-defrosting one. And there's more information related to that if you're interested. But you can put your seeds inside a paper bag and really track humidity and make sure that it drops below the 50%. So the combination of lower temperatures and low humidity can really help you finish drying your seed. If you don't have a lot of seed to dry, this is a really nice option to have too to finish drying your seed. This is used for camera equipment, and this type of cabinet really works to dehydrate that air. So you put your seeds in there, and it keeps track of relative humidity, and your seeds will dry nice and slow. You can see here, even though this area has AC, on top there's it's 70% humidity. So it's quite nice to have this cabinet for small quantities of seed. Because it really helps dry them nice and slow. So when you open this, you can see that you can keep small quantities of seed. You can fill these out, but the more seeds you put inside, the longer it will take to dry them. So if you're doing some breeding, that's a really nice thing to have because it dries things nicely and slow. Another tool to finish drying your seeds is silica gel. These little orange beads change color once they get exposed to moisture. So once they get saturated, they turn this green color, so you know it's time to change it. You normally add the same quantity of silica gel to the quantity of seeds that you're trying to dry, and it really sucks up moisture and reduces the relative humidity, and then your seeds can dry quite nicely. So the take-home message here is that high temperature and high relative humidity will reduce seed germination and vigor, and those are challenges in the tropics when you have rainy seasons and really high temperatures. So ideally, you want to store your seed between 35 and 40 degrees Fahrenheit with relative humidity of less than 40%. Most refrigerators will hold temperature at about 40 Fahrenheit, but have high relative humidity. So if you're storing your seeds and they have been dried down, you want to keep them in containers. Otherwise, you really want to research specifically about that seed that you're growing, and if you want to do longer term storage, you can tweak these parameters to make it work better for you.
All right. Does anybody have any drying questions for Daniela before we go to the next video? All right. Well, while we're watching the next video of Evan, maybe we can everyone chime in who's experienced and share maybe some equipment that you've found useful for drying, and then we'll get started with Evan's video. Oh, someone's asking, do you add the orange beads right to the seeds?
That's a really good question. So you should keep your seeds separate. So even have a little canvas bag or a tray inside the container, just so they're not in direct contact with your seed, because it can damage your seed if they dry too fast. So good question.